All right, let's take a look at number 8. We're supposed to find the area of the circle, and we know that the area of a circle is pi times radius squared. So find the radius, and we'll have number 8 completed. So how to find the radius? Well, what do they give us? They give us a central angle and an area of a sector. So how do we find area of a sector? It's a fraction of the whole circle. What fraction? 25 3/60ths. The part central angle divided by the whole central angle. So 25 3/60ths of the whole circle is the area of the sector, but they told us what the area of the sector is. So 4.1 is going to go into the left side of the equation. So 4.1 is 25 3/60ths times pi radius squared. This is all a number, so we can put this in our calculator and we should be able to determine that that's about 0.21817 r squared. So next we'll divide by that value because we're trying to find the radius so that we can answer this question. So we divide by 0.21817 on both sides of the equation, and that gives us this, and then we take the square root of both sides, and now we've got our radius, about 4.335. So let's come on up here. The area of the circle is pi times radius squared, where the radius is about 4.335. And when we square that and multiply by pi, we should be able to do this in our calculator and get approximately 59.04 square feet. All right, how about number 9 then? In this problem, they're not asking for the area, they're asking for the radius. So find r. All right, so what have they given us? They've given us the area of the shaded sector, and they've also given us this central angle. So since we know the area of the shaded sector, we want to know that sector's central angle. And we know a full revolution is 360, so 360 minus 106 will be this rotation. All right, so that rotation is 254. So we have the central angle for the arc whose area is 27.16. So we're going to set up an equation where the area of this gray sector is a fraction of the whole circle's area, pi r squared. What fraction? 254 3/60ths of the whole circle's area. But we know that this area of the sector is 27.16. So substitute that right there. Now we just need to solve for r. Now solving for r here is going to be exactly like solving for r here. So I'm not going to go through that process because the process is exactly the same here, but I'm going to take a look at this problem from a slightly different perspective. We can, if we prefer, think of all these problems as proportions, where we have a ratio of part over a whole. Part over a whole for central angle, like 254 divided by 360. Part over a whole for arc length, so this arc divided by the entire circumference. Or part of a whole for area, like the area of this region divided by the area of the whole circle. So let's try that. Let's see what happens. 254 degrees is a part central angle divided by a whole central angle of 360. And then over here, we can take this gray shaded region, which is 27.16, and say that is part area when the whole area is the area of a circle, which is pi radius squared. And remember, we're trying to find the radius r. So when we cross multiply now, we'll basically be at the exact same place we would have been if we had done it the original way. And you can rewind and see that that setup basically looked like this. So with the part over whole equals part over whole idea, this proportion, we can cross multiply, and we would have 254 times pi r squared and on the other side, 27.16 multiplied by 360. divide by 254 pi. Remember when you use your calculator, put that denominator in parentheses. That gives us r squared equals 12.25. And when we take the square root, we get our final answer that r is approximately 3.50 meters. Alright, I hope these explanations made sense for number 8 and number 9.